Okay. Overview and perspective, my two stupid, silly, simple examples, and conclusion with meaningful data. So this overview, I don't want to spend too much time on that. It's a bunch of statements. There are a huge number of open questions. We know very, very little. We are getting slowly and very slowly getting more and more used to those problems. So, which means that we understand almost nothing about those problems. Numerical methods, lots of variants. I want to emphasize these applications because this is something that we did 3 years ago. We created a startup with Jean-Michel Lasserie, devoted to Minfield Games, Minfield Game Labs. We just sold it 1 year ago after it grew from 1 person to 30 people. And we sold it to Havas, which is one of the largest advertising company in the world. Okay, so what's the connections between Minfield Games and advertisement? This answer is going to come later if you stay awake. Otherwise it will come, but you will not hear it. Okay, this is too technical. Beyond Minfield Games is major open problem, but let me mention the OLA. So in Europe we call it the OLA. In America they call it the wave, or when they want to be specific, Wikipedia calls it the Mexican wave. The reason for the Mexican wave is because the first time the OLA appeared was during the World Cup of football, not soccer. Football, the only football, European football, which took place in Mexico. Okay, so that was the first time. No one knows exactly why there was an OLA in Mexico. It's a mystery. So maybe maybe there was a militaries behind and willing to execute everybody if they were not doing the OLA. You never know. Huh? I'm sorry to smile about Mexico, but in view of the recent tragedy, unfortunately, those kinds of things are indeed possible. There is a huge scientific literature on the OLA. You may say, well, there is a huge scientific literature about anything. That's true. There's still a huge scientific literature about the OLA. Well, because there are many reasons for that, especially people in computer science and communication networks are very much interested in the OLA, this kind of spontaneous formation of a very organized phenomenon, and which is close to questions that are certainly of interest for people here, like Stephen and you, Felipe, theory of emergence and so on. So there is a big literature on the OLA. Okay? Yes, what's the way, how we handle this question of the OLA. So we need to describe what's taking place in the stadium. And we're going to look at the density on columns. Okay, taking not rows, columns. So the typical stadium, 100 people. Okay, and we consider this to be very large. First assumption, very large. Okay, so then we are going to describe the set of positions through the measures of the people in that column. Positions meaning z equals 0, you introduce a variable. Z equals 0, you sit. Z equals 1, you stand. And z between 0 and 1, this is going to be ridiculous, I know. You're like that, okay? So understood, z between 0 and 1. Then you have to describe the criterion. What do people want to do? Well, they want to minimize their effort. Effort is kinetic energy, z dot square. They want to maximize their comfort, to minimize their discomfort. So z equals 0 is comfortable, sitting is comfortable, standing is comfortable, in between, that's bad. So a very steep function. Okay? Third item, herd behavior. I want to be in the same position as my neighbors. Okay? Depends on the other. So take a local average of the densities in a neighborhood, and look at the difference between your position and this average difference. Okay, that's it. You have two parameters. Make the mathematical analysis, and here's the prediction. If the herd behavior coefficient is not too small, there is a unique, stable periodic wave. Unique up to reversing the sign. Okay? Which means, in particular, if you consider the stadiums all over the world have about the same size, and that people basically have the same type of reaction with respect to crowds, the prediction is that the Ola should always have the same speed all over the world. So then you check, and this speed is always the same. It has been measured. Okay? So I'm not saying, so it's a fact. When the Ola is stable and goes on for several turns, it has always the same speed. And it has been measured very, very, very accurately. There has been lots of experiments during the Olympic Games in Sydney, because it turns out that that was a question I asked some friends from Argentina. I told them, in Argentina, when you go to a football game, does it go the same way or the other way? You know, like the water faucet, right? And I was very excited when he told me it goes the other way, and he was wrong. I checked, and it was just wrong. It always goes the same way. In fact, during the Olympic Games, they made the experiments in Sydney. They made the experiments, and it moves clockwise, always. And they made an experiment to create an Ola that moves counterclockwise, and it moved exactly at the same speed. Let me also mention the physics experiment. I love physics, but sometimes physicists have strange ideas. A physics experiment made in the Netherlands, because some physicists say, well, sure, this Ola looks like a soliton, a solitary wave. So what is the main property of solitons and solitary waves is that when two solitons cross each other, they interact and then decouple and continue their path as if nothing had happened in the interaction. So this was an experiment done in the Netherlands in a stadium. They brought people and they sent two Olas against one another. It was a disaster. Of course, I mean, those are people, you know, not elements of fluids. And you can imagine the poor guy sitting there in the middle, and there is an Ola coming here, an Ola coming there. What am I going to do? So this is typical of, we are dealing with people. We are dealing with people that react, anticipate, and so on. Okay, sorry for being a little bit clownish, but at least you're not falling away.